Okay, the next one we're going to talk about is complementary angles. And so if you remember in class when we measured the different triangles, we found that sine of 30 degrees was the exact same thing as cosine of 60 degrees because your opposite and adjacent sides actually flip-flop in that triangle, and so they actually end up being the exact same ratios. We could look at other things, for example, tangent of 40 degrees and cotangent of 50 degrees are going to be the same. Secant of 80 degrees and cosecant of 10 degrees are also going to be, and remember in geometry, the word complementary means add up to 90. Supplementary angles add up to 180. Complementary adds up to 90. So that's where that comes from. So if you want to look on page 524 in the Sullivan book, it lists all these complementary angles, and we can use these to actually solve some problems. For example, say I give you secant of 28 degrees minus cosecant of 62 degrees, and the directions say something like simplify. Well, you can change either one, but if you look at this one, you're like, well, I'll use a complement, which would go with cosecant of 62 degrees minus cosecant of 62 degrees, and obviously that's going to give you 0. Another problem might be to do, say, sine of 35 degrees divided by cosine of 55 degrees. Again, we want to do these without using a calculator, and so we look at this top one, and we're like, well, that would be the same as cosine of 55 degrees and cosine of 55 degrees. And so then I can obviously reduce that to equal 1. So you're probably going to want to go back and review page 524 to look at the trig ratios that are complementary, but again, it should make sense from what we did in class.